Parting or cutting off is the process of cutting a groove around a revolving workpiece to sever it from the piece held in the lathe. After viewing this videotape, you should be able to write down the safety precautions that are required when parting work on the lathe, describe the procedures for setting up the lathe and parting work held in a chuck, identify some of the tools that are required for parting or cutting off, and identify some of the operations for which cutting tools are used. Some safety precautions must be observed in parting work on the engine lathe. Always wear safety glasses. Remove jewelry, such as watches and rings. Keep your sleeves rolled above the elbow. Work to be parted must be held in a lathe chuck, since one part of the work will be severed. The work setup should be kept rigid. This means as short an overhang in the chuck as possible. And never catch pieces being parted on the lathe with your bare hands. If you want to prevent damage to the part, catch it in a container. A parting cut is made at a right angle to the center line of the work. The tool is fed in with a cross feed and cuts with the end cutting edge angle. Since there is no shear to the cutting action, this operation tends to produce chatter. You can prevent this chatter with a rigid setup. Proper RPM selection and proper feed rate. Cutting off of parts is an operation that is usually performed after the work has been machined, such as turning to a diameter or drilling. The parting or cut-off tool can also be used for necking and grooving operations. Three types of tools commonly used for parting are solid forged types, tools ground to shape from tool bits, and high-speed steel cutter blades, which are held in a special tool holder. Solid forged tools are generally used on the turret lathe or in production operations. They often have an attached carbide insert to prolong the life of the tool. Cut-off tools ground from tool bits are used primarily on small work. The cutting edge may be straight or offset, depending on the requirements of the job. When this type of tool is held in a 14.5 degree tool holder, grind the tool bit to reduce the amount of back rake. Inserted blade tools are made in a variety of sizes and are held in special tool holders corresponding to the size of the blade. The tool holders are available in straight or offset design. The advantages of this type of cut-off tool are the blades can be replaced. The blades can be adjusted in the holder to accommodate varying diameters of work. And the blades can also be sharpened repeatedly before they must be discarded. Blades are manufactured with beveled sides to provide side clearance, so grinding is necessary only on the end of the tool. All three types of cut-off tools are of the same general shape. They are ground so that the nose, which is the cutting edge, is the widest part of the tool. Both sides of the tool are ground with 1 or 2 degrees of side relief and 1 or 2 degrees of back clearance or flank relief. Back rake is usually not desirable for parting softer metals such as brass. For harder metals such as steel, you can use a back rake of about 5 degrees to give a freer cutting action and curl the chip. Use approximately 15 degrees of end relief for soft materials and approximately 10 degrees of end relief for hard materials to give added support to the end cutting edge. A parting tool should be ground for maximum strength and set up with an overhang just slightly greater than 1/2 the diameter of the work to be parted. To perform a parting or cut-off operation, Mount a workpiece in the lathe chuck with a minimum overhang. Set up a properly ground cutoff tool with minimum overhang. Set the spindle RPM to a rough turning speed. The feed rate should be set to produce a thin, continuous chip. If chatter occurs, decrease the spindle speed and increase the feed. If the tool gouges or digs in, reduce the feed rate. If you are using a power feed, the setting should be approximately 0.02 of an inch per spindle revolution. To part tubing or small parts, however, hand feed is more desirable. Set the tool to exact center height and align it perpendicular to the center axis of the work. This keeps the tool from rubbing the sides of the cut. A common parting operation is cutting off a number of pieces of the same width from bar stock. The compound rest, set parallel to the ways, provides an easy way to measure these parts to length. Touch the tool to the end of the work. Bring the tool outside the diameter and lock the carriage. Move the compound the width of the tool, which aligns the tailstock side of the tool with the end of the work. Now move the compound over the desired width of the part to be cut off. In this case, move it over 125 thousandths. Engage the spindle and touch the parting tool to the work. Apply an ample amount of oil to the top of the parting tool and engage the power feed. Be sure to keep applying oil to the parting cut. When the cut is completed, disengage the power feed and back out the tool. Then move the compound over the thickness of the tool plus 125 thousandths. Engage the power feed and make another parting cut. Continue the process until you have produced the specified number of parts. Another common cutting off operation is parting tubing. Place the tubing in a chuck. Remember to avoid unnecessary overhang. Set up the parting tool in a tool holder. This tool has 1 to 2 degrees side relief, approximately 15 degrees end relief, and approximately 5 degrees back rake. Mount the tool holder in the tool post. Set the spindle RPM. There is no feed rate setting for this operation since you will be hand feeding the tool. Touch the tool to the end of the work. Back the tool away from the work diameter and lock the carriage. With the compound, move the cutting tool over the width of the cutting edge. Then move the tool over the specified length of the part, in this case 250 thousandths. Engage the spindle and feed the tool in to touch the work. Apply oil to the tool and the work, and at the same time, feed the tool by hand to remove a thin, continuous chip. When the piece has been severed, back out the tool. To produce more rings of the same length, move the compound 250 thousandths, plus the width of the tool, and repeat the operation. Parting or cut-off tools may also be used for necking and grooving. Since the shape below the surface will follow the shape of the tool, parting tools will cut a square groove or recess. To use a parting tool for necking or grooving, set up the tool and the machine as you would for parting. With the workpiece blued, lay off the mark where the groove is to be cut. Using the carriage and crossfeed, touch the tool to the work with the edge of the tool at the line. Set the crossfeed dial to 0. This groove will be 100 thousandths deep, so apply oil to the tool and feed it by hand a distance of 100 thousandths. Back the tool away from the work. If the groove is to be wider than the tool, move the compound over the difference between the width of the tool and the specified width of the groove. In this case, move the cutting tool over 75 thousandths. Then feed the tool back into the work, applying oil while the cut is being made. Remove material to a depth of 100 thousandths to match the depth of the previous cut. The grooving operation using a parting tool is now complete. In this videotape, you have been shown a number of safety precautions that should be followed when parting work on the lathe, different types of parting tools, and typical parting operations. You have also seen how to use a parting or cutoff tool for recessing and necking operations. Knowing how to use these cutoff tools efficiently will make you a better machinist.